questions say? It says, if the function is 1 to 1, then you find its inverse. If it is not, then you write not 1 to 1. Now, what functions are not 1 to 1? Well, if it has a square in it and not restricted on the domain, like 6 would have an inverse, but 7 has no inverse, okay, because of the square. Oh, thank you. I can do an extra one.
No, that was.
I do what now?
I said it was 7. We're on 2 different.
Oh, sorry about that. Yep, we got the right ones now. All right, so I know I have intermediate right before this. Easy to get them all mixed up. All right, thank you very much, Gabby. Yeah, that was my mistake. I probably grabbed them out of the wrong pile because I thought I'd put all the intermediate up, but it's easy to do. That's why I've got them labeled. But it's easy for me to grab from the wrong stack. Okay. So let's now look at question number 7. Okay, so some of these, if it doesn't have an inverse, all we have to write is not an inverse. So this is your homework, 4.1. We're going to start with question 7. Now, if it has no inverse, there's not much to do. So question 7, it doesn't even have an inverse. Why would this one have no inverse? So if it has no inverse, you just write not 1 to 1. Why does this one not have an inverse? Why is this one not 1 to 1? Well, it is not 1 to 1 because of what? The square. Okay? So if it has a square like that, it is not 1 to 1. However, question 6 does have an inverse. And we can actually look at question 6 next if we need to. So question 7 had no inverse. Now, question 6 does. And we did one like this in class that was very, very similar to it. So we did one like this in class last week. So why does this one have an inverse? Because it has a restriction on your domain. Right? Even though it's squared, it has this restriction. So that means it's going to have an inverse. So we replace, to find our inverse, remember our rules, we replace that f of x with the y. So that's our first step there. And now what do? Now we interchange our x and our y. Sorry, that should be a y squared there. Minus 25, and that x becomes our y, which we'll deal with that in a moment. Now, what do we do from here? So we replaced f of x with y. We interchanged your x and your y. Now you have to solve for what? You have to solve for y. We need to get rid of a square root. How do we get rid of a square root? Square both sides, right? Okay. So we're going to square both sides. Now, when we square a negative, what happens to it? When we square a negative, it becomes a positive. And what happens when we square a square root? Well, when you square a square root, the square and the square root cancel. Now, what do we need to do? We need to go ahead now and solve this for what variable? We need to solve this for y. So we're going to move that 25 over. Now we've got y squared equals x plus 25. And how do we get rid of a y squared and make it y? We take our square root. So We take our square root. That gives us with y equals now. Don't worry about the plus or minus because it can't be negative. So that gives you y equals the square root of x squared plus that 25. We replace y with f inverse. So f inverse of x is now square root of x squared plus 25. And we have a new domain. X has to be now, because we put the y in here and solve it through, x has to be, going back to our original, okay, we look at our x and our y, we switch them around. So x has to be now less than or equal to 0. Don't worry so much about the domain here. That's a little bit tricky. But what I'm really wanting to make sure is that you at least get this part. If you get the domain over here correct, that's great. At least get to this part. So that's what you need to do. Make sure you solve it out and get to at least this part. Let's do another one, just to make sure we know how these work. So let's look now at one more of them. Let's look at question 10. So, same directions. What we need to do is find the inverse if it has an inverse. So, when I look at this, does it have an inverse? That's the easy part. What does not have an inverse? Absolute values do not have an inverse. Squares do not have an inverse unless they have a restricted domain. Well, this is a cube, right? So it will have an inverse. So what do? We replace f of x with y. Then we swap out, or we interchange the x and the y. Now what do? Since we switched them around, we now resolve it for y. So we're going to add on our 8. And we have y cubed equals x plus 8 when we moved it over. And remember, way back from that first chapter, how do we get rid of a cube? Well, when you have a square, we use a square root, right? When we have a cube, how do we get rid of a cube? We use a what? We use a cube root. So put the cube root there. Now when I rewrite that, we have y equals the cube root of x plus 8. And we replace our y with what it now is, which is our inverse. So f inverse of x is the cube root of x plus 8. Is everyone okay with that now? If we don't have any other questions, then we'll move on. And we're going to start the rest of chapter 4 today. So that was... Do what now? Which one? The one, 3-7? Yes, I do. Yep. That should be the one that should be, right? All right. So let's move on now. We're going to look at today 4-2, and on Thursday we'll look at 4-3. And if you ever need the homework packet, when you're working at home, or you want a new one, you can always print them off in Canvas. So put everything in Canvas. So along with the notes, you can always get the homework packet. So if you ever lose one and you're working on it on the weekend and need the homework packet, you can always print it off. So your Canvas modules. I always have extra copies, but in case you're gone and look it up, you can always print them off. So today, we're going to be looking at exponentials. On Thursday, we're going to be looking at logarithms. So exponentials today, logarithms on Thursday. Now, exponentials are just powers. So these have powers. Normally, we don't have an x as a power, right? It's down below. So we're going to go ahead now and look at exponentials. And we're going to talk about these graphs first. And once we've talked about the graphs, then we'll learn how to use exponentials to solve some equations. So if we go to the back cover of our textbook, down at the bottom on 4.2, we have what are called exponential graphs. And it's either going to go up from left to right or up from right to left. So one way or the other. It's either like this or like that. Now, everything that we've learned so far makes these behave just like everything else. So you can move it up, you can move it down, you can move it left, you can move it right. So let's graph a few of these. Now we have two of them because we have two different graphs. One is for a base bigger than 1. One of them is for a base less than 1. So this is the first one that we're going to look at here. I'll just rewrite the graph. And this one is a base bigger than 1. And it has specific points that we plot. So it's going to have some specific points that we use here. We always have this 0, 1 here. And then we have 1, comma, A here. And so its graph is going to look like this. Now it doesn't show it, but there is actually a horizontal line. Okay, it doesn't show it, but there is actually one. And I like to put it there. That way you make sure you know what it should look like. But that's the shape of it. And that is when your base is bigger than 1. And an example, or examples might be these. F of x equals 5x. F of x equals 8 to the x power. Those are going to look like this. The base is the 8. And 5 is definitely bigger than 1, and 8 is definitely bigger than 1. The other graph is when your base is between 0 and 1. So if your base is between 0 and 1, it looks like this. It's the opposite. And we always have that point 0, 1. That's a common point that we have. We have another one up here, and that's going to be minus 1 over A. And it looks similar again. It's just that it curves in this direction. And what are some examples of this one? Well, anytime you have a fractional base. So 1/2 to the x power. Or let's say f of x equals 1/10 to the x power. They're going to look like this. So if you have a fraction, the graph looks like this. If you have a number bigger than 1, it looks like that. These, again, have that horizontal line at 0. Now, all the same translations that we normally do are still going to apply. So we can move it up and down, left and right. Let's start with the first, with a really easy one here. And let's try to graph this one. Let's try to graph f of x equals 4 to the x power. Well, if I graph 4 to the x power, okay, it should look like this. When we're done, it should look like this. Why? Because 4 is bigger than what? Bigger than 1. Now, we always start with that point 0, 1. That's where you start at. We don't start at 0, 0 anymore. We start at 0, 1. Okay, so that's where we're going to start. Zero, 1 here. That's going to be right there. Okay, so 0, 1. Now, this is our A. And we have some points that we need to get. We need to get 1, comma A. Well, what is our A? A is 4, see, so we're going to have that point 1, 4. And where would 1, 4 be at? 1, 4 would be over 1, and then up 1, 2, 3, 4. So right there at 1, 4. And we also need minus 1, 1 over A. What would minus 1, 1 over A be? Well, our A is 4, so if I flip it over, what do I get? 1/4. And see, that's going to make my curve look like our first graph. Because here we are at minus 1, and then we've got positive 1/4 here. And we connect them together. Now, we didn't move it up or down any. So we still have the same horizontal line here. We connect them together. There's your graph. So that's what it will look like. Let's do another one. Let's try to graph this one. Let's try to graph f of x equals 1/3 to the x power. So we're going to try to graph this one. So why is my graph going to look like this? Why is my graph going to look like this? Because that 1/3 is what? Between 0 and 1. Right? So if it's a fraction, the graph looks like that. If it's a whole number, it looks like that. Right? So see if it goes up or over, depending upon the value here. Okay, so we know it should look like what? Ready? Quick sketch over to the side. It should look like that. Basic graph. Let's pick our points. Where are we going to start at? We don't ever start at 0, 0 on these. We start at 0, 1. Now, we also need some points. We need 1, comma A. And so what would that be? Well, A is this 1/3. So my point would be 1, comma 1/3. Right? So there's another point. We need our 3 points to connect them together. And then we also need minus 1, comma 1 over A. Well, what would minus 1, comma 1 over A be? What is 1 over A? If I take a third and I flip it over, what do I get? 3, right? So what does it look like when I plot my points? We're going to start at 0, 1, which is right here. Then we have 1 comma a third, so that's right about there. And then we have minus 1 up 3. We can now connect these together. And again, we still have our horizontal line here at 0. And there is my graph. But you need to find those 3 points. Let's do 2 more of these just to make sure we have them down. We'll do 1 more with the fraction, and then we'll look at one that has a negative power. And we'll talk about what that is going to do. So let's try to graph this one. Let's try to graph f of x equals, how about four thirds to the x power. Okay, now, let's talk about our pictures here. I'm going to put these over to the side so we can see which one it's going to look like. Now, it's not going to look like this one. Why not? 4 thirds is a fraction, but what do we know about 4 thirds? Let's use our calculator. Well, 4 thirds would be what? 1.33. And 1.33 is bigger than what? Bigger than 1. So what should it look like? All right, it should look like this. Why? Because this is bigger than 1. Now let's find our values. So we always start at 0, comma 1. Nothing ever changes. That's where you want to start at. You can shift them up and down as well, but I'm just focusing today on the basics, but you could add a number on the end and that would move it up. But we're not doing that. We're just always going to have it start at 0, 1. And we need to find now our points. So we need 1 comma a. Now, 1 comma a, what would that be? Well, that would be 1 comma 4 thirds. We also need minus 1 comma 1 over a. Now, what would that do? When I have minus 1 comma 1 over a, well, that would be minus 1. And I flip this over, and that's going to be now 3/4, which is 0.75. So see, it's going down. So what does the picture look like? Let's plot our points. Where do we start at? We always start at 0, 1. So that's right here. Then we need 1, and we need 4 thirds. Now, 4 thirds is what? 1.3. So it's going to be a little bit bigger than 1, but less than 2. So it's going to be right about there. Also, we have minus 1, and then it's 3/4. So that's a little bit less than 1, so it's going to be right about there. We know we have a horizontal line here still at 0. We can now connect these together. There is my graph. Okay. When you have a negative exponent, it's going to flip it around and make it go the opposite direction. So let's try to graph this one. Let's try to graph. And there's only one of these in your homework. Let's try to graph f of x equals, how about 3 to the negative x power? Well, no matter what, we always start at 0, 1. That's a fixed point. It never changes. That's where we begin. let's try 1. Let's plug in x equals 1 and let's see what happens. If I plug in x equals 1 here, that is then 3 to the negative first power, which is 1/3. So that is now 1, 1/3. So that's a point there, right? Because it's a negative exponent. Remember what happens with your negative exponents. They become fractions. What about if I plug in x equals a negative 1? Well, if I use x equals a negative 1, then that's going to be 3 to the minus 1. Negative and negative makes it positive. So that's 3 to the first power, and that is simply 3. So that's going to be minus 1, positive 3. All we need is these 3 points. What it's going to do is that negative is going to make it go the other way. So instead of like all the others did, where they would go up like this, the negative is going to make it go up like that. Let's plot our points and see. So we've got 0, 1, which is right here. We've got 1, 1/3, which is right about there. And we've got minus 1 up 3, which is right here. We can curve them together. Don't forget, we still have our dotted line here. So we're going to curve these together, just like that. And there is my graph. So what did that negative do? Well, instead of looking like this, it flipped it over and made it go like that. That's all it did. There's only one of those in your homework. Now we're going to talk about these equations, how we can solve these exponential equations. Some of them are much easier to solve than others. I'm going to pick some from our textbook. We're going to look at some easier ones, and then we'll build up to some harder ones. Now, what we're going to do is we're going to use our algebra skills to try and find x. So let me pick a couple of these from our textbook. We're going to start off with a very, very easy one that we can just pretty much look at. So I'll just make up an easier one for us to start with. And these will just be solved. Okay, and this is going to be a pretty easy one to work through. So let's take a moment to just look at this one. This one, you can probably just see it and figure it out. So when I look at this one, what do we know? Well, we need to take 4 and raise it to some power to make it 16. Now, when we look at these, we either want the bases to be the same, the numbers below, or we want the powers to be the same. So what do we know about 16? Well, we know that 16 is 4 squared, right? So 16 is 4 squared. So look what happens when I rewrite 16 is 4 squared. Now you can see what x is going to be, because what do we know? We know that these bases are the same. If the bases are the same, then the exponents must be the same. So what does that tell us then? Well, that tells us that x must be what? 2, right? If these bases, the numbers below, these again are called our bases. If the bases are the same, then the exponents must be the same. So that one we just converted it, we got a common base. And that's one of the techniques that we're going to be using. Let's look at another one here, and I'm just going to pick these from our textbook. We're going to try to convert one base to the other. So let's try question 72. And This is going to be on page 460. So page 460. We're going to look at question 72. Now we're going to use the same procedure that we just did a minute ago. And what we're going to try to do is we're going to try to get a common base. And so we take our smaller base, which in this case is a 5. And we're going to take 5 and we're going to raise it to some power to make it 125. Well, what number is going to go in the box here? Well, we know 5 to the first power is 5, right? 5 squared is what? 25. But what about 5 cubed? Well, is 5 cubed 125? It is, isn't it? Because that's 5 times 5 times 5. So now we can rewrite this. We always rewrite the larger one as the smaller one. So we know that 125, we can write that as 5 cubed. We still have the x there. And that equals 5. And I'm going to put the 1 there. Putting the 1 there is like a placeholder just to make sure we see it. So we have to put that 1 there. We need it. And what do we now know? Are the bases the same? Yes. These values are the same. So then that means we have 3x equals 1. Divide by your 3. And my answer is now x equals 1/3. That's it. So in that case, we want to make sure that our bases are the same. 74. A little bit different on 74. So 74 is 2/3 x equals 9/4. Well, in some cases, we may have to flip it over. Because when we look at it as it is right now, 2 squared is 4, 3 squared is 9, but that doesn't work because this fraction's upside down, right? So let's rewrite this. I can rewrite this as this. I can look at it as 9/4 is going to be 4/9 to the negative first power, right? Because you could flip it over. Remember your negative exponent rule. So sometimes you may have to use that negative exponent rule. Now, what do we know about these bases now? What do we know about 2/3? When we raise it to a power, we get 4/9. Can anyone tell me what's going to go in the box here? Well, we know that 2 squared is what? 4. And 3 squared is 9. So what's going to go in the box? 2. So now when I rewrite this, I have 2/3 to the x power equals, we're going to have a 2/3. Now we have the 2 there from here, times that by -1, so that's going to make that a -2. So we just multiply those exponents together, and that makes it that -2. Now, what do we know? Are the bases identical? Are the bases the same? Yes, these are the same. So what does that tell me about my value of x? Well, that tells you then that x must equal what? X must equal a -2. Is everyone okay with that? All you have to do is make sure those bases line up. Simple enough. In some cases, you may have to convert both of them to a common base. question 79. This is going to require us to convert both of them. So question 79 is 27 to the 4x power equals 9 to the x plus 1 power. Well, what do we know about 9? Well, 9 squared is 81. It's not 27, is it? We need to figure out how to convert them. What do we know about 9 and 27? Well, 9 is a perfect square of 2, right? Sorry, perfect square of 3. So 9 is a perfect square of 3. What do we know about 27? 27 is a perfect cube of 3. That's our common base. So we know this. So we want to note this fact. We know that 9, if I can write it correctly here, is 3 squared. And we know that 27 is 3 cubed. So that's going to be our common base. Okay, we need the same base here. And we know that 9 and 27 both are common bases of 3. So let's rewrite this. Now we'll handle the powers by using parentheses. So that 27 becomes 3 to the 3rd power. And what's still up there with it? 4x. So that just comes along with it. And then we know that 9, well, 9 was 3 squared, so that's 3. We bring that 2 up, and we put parentheses around what's left over, which is that x plus 2. Sorry, x plus 1. So is everyone okay with that? Now, what do we know? Are the bases the same? Yes. If the bases are the same, then what do we know about the exponents? They must be the same. The bases are the same, so 3 times our 4x has to equal 2 times x plus 1. And we know that 3 times 4, that makes it a 12x. We'll distribute our 2 through here. So that's going to make it a 2x plus 2. We'll move that 2x over. So 10x equals now 2. Divide by your 10 and reduce it down. And what does that give you your x value to now be? X should now reduce down and give you 1 what? 1/5. Let's look at one more of these just to make sure that we know how to get these common bases. I'll make up a pretty easy one here. Well, actually, I'll just pick one. How about 80? Let's look at 80. Instead of me making up one, I'll just pick one from our textbook. So 32 to the 2x power equals 16 to the x minus 1 power. So we're going to proceed exactly the same way that we did the last one. What do we know about 32? 32 is not a power of 4, is it? Not a power of 16. But what do we know about 32? Well, we know, we use our calculator, okay, we know that 2 to the 5th power is what? 2 to the 5th power is 32. So that's where we're going to work from. We know that 32 is 2 to the 5th. Now, what do we know about 16? We want a common base, so we know we're going to try to use a 2 for a base. We know that 2 squared, right, is 4. 2 cubed is 8. What about 2 to the 4th power? 2 to the 4th power would be what? 16, and that's what we want. So 16 is 2 to the 4th power. That then gives us the common bases that we need. So 2 to the 5, we'll multiply that by the 2x that's already there. And that 16 becomes 2 to the 4 power times x minus 1. Now, what is always our goal? Our goal is to make sure that these bases are the same. If those bases are the same, then we know our exponents must be the same. So that tells you then that 5 times 2x must then equal 4 times x minus 1. And multiplying, that gives you a 10x and a 4x minus 4 here. That 4x over. So 6x equals now a negative 4. We'll divide by our 6 here, and we're going to reduce it down. And that reduces down now to a 2/3. So what is my final answer here? X equals what? Negative 2/3. That was question 80, and sometimes you may have to do that. You may have to get a common base. In many cases, they don't have the same base. But you look for things like 16 is 4 squared. 4 squared is 2 squared. So then I could get that 2 to the 4th power. And I knew that I could do the same thing with the 32. So it's just a matter of making sure that you get the same base. Now we're going to look at some where we have to find the base, find the x value down below. So let's look at 84. This one's a little bit different. (84) is going to be x to the 2/5 power equals, in this case, 16. Now, what we need to do in this case is we need to figure out how to get the bases to be the same. So the first thing I'm going to do is I am going to work with clearing out these fractions. So the first thing I'm going to do, bless you, is I'm going to take both sides to the 5th power. So I'm going to do that. Take both sides to the 5th power. I'm going to leave that 16 to the 5th power. I'm going to leave that alone for right now. So that leaves you now with x squared equals 16 to the 5th power. You can use a calculator and you can work this out the way that you normally would. But let's try to make it as easy as possible. What do we know about 16? We always look for squares and cubes. Well, we know that 16 is 4 squared, right? So let's rewrite this now as 4 squared. This one we don't have to get a common base because we can use other techniques. And now we know when we have our exponents like this, we can multiply them together. Now let's think about how we would do this. And you've done these before. Many times you've done these before. How would I solve for x here? How do I get rid of a square? What undoes a square? Square root. Okay? Now, always make sure you remember whenever you take a square root, what does that do? That makes it plus or what? Plus or minus, right? So don't forget that. So let's see what we get here. We'll take the square root of both sides. Don't forget your plus or minus. So let's rewrite it and see how we would get our answer. So x equals now plus or minus the square root of 4 to the 10th power. When you take a square root, you half the power, okay, because it's squared, so you're going to half it. So whenever you take a square root, okay, that's going to half your power. So the reason why I split this up is because I can't really half 5, but 10 I can. And what's half of my 10 here? 5. So that gives you x equals now plus or minus 4 to the 5th power. And if you want, you can leave it like this, or you can split it up. And 4 to the 5th power would be 4yx here to the 5th power. Okay, that's going to be 1024. So your two answers would be positive 1024 and a negative 1024. Why do we have two of them? Because we took a square root. Now, if you take a cube root, you don't use the plus or minus. You only use the plus or minus on even roots. So that's question 84. Right, so does everyone see how we did that? We got rid of our fractional power. And then we kind of manipulated the powers around. You could have just used the calculator from the beginning. You could have just done this. You could have said 16 to the 5th power is that. Take your square root, same thing. I just chose to break it up and use the exponent rules, but you could have just done it in your calculator. You could have just took it to the 5th power and then took your square root and got the exact same answer. Okay, let's try another one. How about we look at question 89? So question 89 is x to the 5/3 power equals a negative 243. Now we do have to be careful with our signs here. The first thing I'm going to do is I'm going to go ahead and I'm going to take both sides to the 3rd power. That's going to make my life a little bit easier. So now we have this. We really need it to be a multiple of this 5. So let's see what we can do with this 243. See how we can break this down. Well, 243 is not a perfect square, but we do know we usually use the smaller powers to work with this. But what we do know is we do know that 243 is going to be 3 to the 5th power. You just want to play with the numbers until you find it. Okay, so that's going to be 3 to the 5th. And this just makes it easier this way. Now, what happens when I cube a negative number? When I cube a negative number, does it stay negative or does it become positive? Well, if we remember, when we square a negative, what does it become? Positive, right? But when we cube a negative, it stays what? Negative. So when you cube a negative, it stays negative. So that becomes now negative 3 to the 15th power. You can just bring that out. Just like that, because that negative stays negative. That's just one of the properties. When you cube a negative, it stays negative. When you square a negative, it becomes positive. Now what can we do? Well, just like we did before with the squares, to get rid of a square, we use a square root, right? To get rid of a 5th power, we're going to use a what? 5th root. Now, the only time we need to worry about plus or minuses is with squares. Square root, remember, plus or minus. Cube roots don't, fifth roots don't, seventh roots, odd powers don't. So we can go ahead and take the fifth root of both sides. Or you can use a 1/5 power. It's the same. That cancels with that, so that gives you your x. Now, what we have is then we still have a -3. And what do we know about these? These divide. 15 divided by 5, these divide out. So 15 divided by 5 is a 3. And what do we know about 3 to the third? 27. So what would our final finished answer be? X equals -27. You could have also done this, if you prefer, with a 1/5 power, if it's easier. Okay, I'll show you that. Some students might find it easier to use fractional powers instead of roots. It's just you have to be very careful with the squares. I could have done this. I could have said, take both sides of the 5th power. Right, same thing. And those cancel. That gives you an x. And what's 15 divided by 5? That's the same 3, which is then the same -27. Right? You can either use a fractional power or a root. Where you have to be careful of is with square roots, because they have a plus or minus. Others don't. Odd powers do not, even powers do. So this still works, and you can take the square root. You can't take the square root of a negative number, but you can take the 5th root or the cube root of a negative. So let's try some now where we have to try to get the bases to be the same. So let's look at, how about question 95? We're going to look at question 95. A little bit different on this one. There's several different types of questions. They're solved a little bit differently, but the main goal is to try to get the x where you could use some property. Maybe the square root property. Maybe you can get the bases to be the same, so that forces the exponents to be the same. This one, we're going to have to try to get the exponents to be the same. So this one, we have 1/27 equals x to the -3rd power. So what we're going to try to do here on this one is we are going to try to make this come out to be a -3rd power. How can I do that? Well, what happens if I take this to the -1st power? Let's work with this 1/27. 1/27, if I flip it over, is going to be 27 to the -1st power. We're using our negative exponent rule. Is everyone okay with that? Right? Because we can flip that over. Now we're getting closer. See, these are both negatives now. Sure. Make sure it's the right one here. Yep. Okay, no problem. And there. And I think that kind of worked. Okay, so here we are. Now we need to get this to be a -3. What do we know about 27? We've worked with 27 a lot. We know that 27 is 3 cubed, right? See how we have to get common base, common powers here. So what can we now, thank you, what can we now rewrite this as? We can write this as 3, okay, this was a negative here, to the -3rd power equals x to the -3rd power. Now, what do you know? These now are the same. So, if the exponents are the same, then the bases must be the same. So what does that tell me here? Okay, if The exponents are the same. Yep, I'll mark that. Yep, you can, yep. So what do we know? We know that if these are the same, those must be the same, so x must now equal what? 3. We had to work it out and get it to that point. We had to use some different manipulations to get to that point. Question 96. Very, very similar. You'll do it the exact same way. It's 1 over 32. Well, I don't want that 1 over 32. So what can I do? I can rewrite this as 32 to the negative first power. And what do we know about 32? We've used this several times. We need a power of 5. So we know that 32 is 2 to the 5th power, right? So now we can write this as 2 to the negative 5th power equals x to the negative 5th power. What do we know? These are the same. So that means the bases must be the same. So that means then that x must equal now what? X must equal 2. The last part of this section is going to be working with, well, we've got 2 parts left, working with compound interest. And then we've got some applications on the back that require us to use a calculator. But let's talk about compound interest. This is our formula for compound interest. So if you go to the bank and you take out a loan, this is the formula that they use. Compound interest is this. A equals P to the 1 plus R over N to the Tn power. All you have to do on these is plug in the components. So P is the principal starting amount. So P is the principal. I call it just the starting amount. We've got A, which is that is going to be the ending amount. Future value. That's going to be your future value. Sometimes it's called the future value principal. Sometimes it's called the present value. So sometimes that P is called the principal. Sometimes it's called the present value. Sometimes it's called the starting amount. A, you can refer to that as your ending amount, which a lot of times that's what I use. It's also called, in some cases, the future value. So if you see future value, that means your ending amount. N is the number of compoundings per year. So quarterly would be 4. Monthly would be 12. And yearly would be 1. Okay, so N is the number of compoundings per year. How many times are we taking the payment out? So if it's quarterly, you do it 4 times a year. Monthly, that's 12. Yearly, that's 1. Semi-annually, that would be 2. And R is the last component here. R is the rate as a decimal. R is going to be the rate as a decimal. So we're going to be finding on these, I had always just find the future value. You could find the present value. Most of the time I have you just find the future value. So we'll do a couple of these, and then we'll look at the last questions here. So here's our formula. We're going to come back to that. So leave it up here so we can see it. And all these have the same direction. They're going to be find the future value, find A. So we're going to be trying to find that A. That's our ending value, our future value. So I'll just make up some numbers here. And let's say 10,000 invested for 3 years at 5% compounded monthly. So we're going to look at this. So we're going to take $10,000 and we're going to invest it, maybe put it in a CD, maybe put it in a CD for 3 years. It gets 5%. We're going to compound it monthly. So we need to figure out how much this would be. We want to find the future value, the ending amount. So let's take our formula and come up with our pieces. So here's our formula. A equals P times 1 plus R over N to the Tn power. So what do we know? We know P is a starting value. That's your $10,000. So we start with 10,000. We need the R. R is that 5%. So as a decimal, that would be 0.05. Okay, so there's that piece. We need our T, not to be confused with the N. T is 3 years. And what would my N be? How many times am I going to compound this per year? It's monthly, right? So my N would be what? N would be 12. Plug our values in, and then we work it out. Now I'm going to show you how to use your calculator to work out these powers. I've got 2 different styles of calculators. So I'll show you the 2 most common ways this is done. So no matter what, the first thing you do is you work out the inside. So we always do that first. Before we do anything else, we do that. So we're going to take our decimal. So 0.05, we're going to divide that by our 12. And we're going to add 1 to it. And we know that 3 times 12, we'll do our power next up here. 3 times 12, well, that's a 36. Here's one way of doing it. On this style of calculator, here's my number. You don't have to write it down. All you have to do is keep it in your calculator screen. The only reason why I wrote it down is so you can see it. Now, we want to raise it to the 36th power. So in this style of calculator, you're going to have a YX key. So you would hit the YX key, 36. You're going to hit your equals key down here. And then you're going to multiply it by your 10,000. And that comes out to then be a future value of $11,614.72. A lot of you have a different style of calculator. A lot of you have this calculator. This is probably the most common calculator now. Okay, for this calculator, you see you don't have a y-axis key, you have a caret key. So what I would usually do is this. Clear it all out. We'll type our 0.05. We'll divide that by 12. 12 there. Right numbers here. 12. We'll add our 1 to it, and that's that. Now, what we need to do then is we hit our caret key. And what do we need to raise it to? Notice I use a caret key. 36. We hit our equals key. Multiply it then by the 10,000. And that gives us the same value. So you're either going to use a y-axis key or you're going to use a caret key, one or the other. So let's do one more of these, and then hopefully we'll have time to work through these exponentials quickly. So we'll do one more. Now that was monthly. Let's change it to quarterly. So again, we're going to find the future value. We're going to find the A. And let's say we have $5,000 invested for 8 years at 3.9% compounded quarterly. So this is going to be compounded quarterly. What are our components? I always like to write up our formula. So A equals P times 1 plus R over N, T and T power, same thing. Now, we always find the future value, so we start with $5,000, so that's my P. Our R is that 3.9%, so that's 0.039. Our T is 8 years, but what about our N? Can anyone tell me what the N is going to be? If we're doing it quarterly, how many quarters are in a year? 4, right? So what would our N be in this case? 4. Now we simply plug our values in. So we've got our 5,000 times 1 plus 0.039 over 4 to the 8 times 4 power. This is nothing but a calculator problem now. So we'll just work it out. Now, first thing I do is parentheses. So we take our 0.039. This is the way I usually do it. Divide that by our 4. Add the 1 to it. That gives us that part. Now, 8 times 4, that's 32. So we're going to hit our caret key. Right? Caret key right here. Hit our caret key. 32. That gave me this. And then what do we still have to multiply it by? 5,000 out in front. And so when I work it all the way out, that gives you this. So that gives me a future value now of $6,800, and it looks like $20.46. So that is what you will have at the end. At the end of those 8 years, you would end up with $6,820. We do have a little bit of time left. I think we have enough time now to use our calculator to work out some exponentials. I'm going to do one of these for you. So I gave you 3 of them in your homework. I'm going to work out question 9. So I'm going to now leave 14 and 15 for you to do, but I'm going to work out question 9. This is nothing but a calculator question. So I'm going to do 9 for you. You can do 14 and 15. The decay of 243 milligrams of an isotope is given by this. So radioactive isotope decays over time, where T is time in years since the initial amount of 243 grams was present. Find the amount left after 72 years. All I need to do is use my calculator with that 72. So that is going to be my T. So let's write up our formula. I'll show you how to plug it in the calculator. And this will be our last question. So we're going to be looking at homework question section 4.2. We're going to look at question number 9. So here's our formula. T equals 243E, which we'll talk about that in a moment, to the minus 0.014 T power. And we want 72 years. So we're going to plug in that for the T. So this is my T. I'm going to pass out the sign-in sheet in just a moment here. I'm going to plug the values in, and then while you're writing that down, I will then pass out the sign-in sheet. Now, what E is E is a special number. Just like pi. Okay, pi is 3.14. It goes on forever. It's built into your calculator. Well, the same thing with E. E is named after Euler. It's a number. It's built into your calculator. Now, what it is it's the opposite of the natural log. It's the opposite of the ln. You see on the ln here, see that, I know it's kind of hard to see it in blue, is the e to the x. We're going to be using that key. So the first thing I do is I'm going to work with this. So let's take our calculator and let's work this part out. So I'm going to multiply that together. So let's go ahead and do that real quick here. Let's do that. We're going to write the number down. So minus 0.014. We're going to multiply that by my 72. Let's make sure I did it with the right number of zeros here. And that's going to come out to be a minus 1.008. Right? If you round. Because we're just going to plug our values in. We're plugging in that 72. So 72 times 0.014. That gives you that. And it's negative, so we bring it down. How do we handle this? Notice we need an E. Well, we have an ln key in our calculator. So we're going to hit the second, because it's in blue, ln. That puts the E on the screen. That's what we want. Now go down to the bottom. Don't use this negative symbol. Use this one with the parentheses around it. So hit that. Okay, that's going to put that negative there. And what's our number? 1.008. Just like we've got there. Then we hit equals. So that gives me that. And what do we still have left to do? We still have to multiply it by that 243. There's our final answer. And how far does it say to round? It says round it to the nearest milligram. So that would be, if I round, it would round out to be about 89 milligrams. It says round to the nearest milligram. And there is your answer. So plug the values in. How do you find the E, though? E is second ln. If you have a calculator like this one, it's going to be inverse ln. Either way, it's either inverse or second ln. Please make sure that you sign that sign-in sheet. And what's your homework? Well, your homework for next class period is going to be 4.2, and you should be able to do them all. I will see everyone then on Thursday. If you haven't picked up your old homework,